All right, we're recording. I'm here with Josh Waller from Phala. Thanks for taking the time to the interview on this research project. Josh, can you tell the viewers a little bit about yourself and what you do at Phala?
Oh yeah, thank you. Yeah, thanks for having me. Yeah, I'm Joshua. I'm a developer advocate and a dApp developer for Phala. So I help build out the Phala World palette for that's like integrated into the Call parachain. And I also helps integrate remarks like NFT palette into the Phala World palette as well. And then also I build decentralized apps on fact contracts, and from there I also teach and help out others as I travel, like kind of like around the world to like kind of teach these fact contract seminars and workshops for different developer conferences, just randomly. So I have one at like the end of the month at Sub-Zero, so that would be pretty nice.
Excellent. So can you tell us a little bit about the palette you did with Remark and the work you did with that and kind of the functionality in that?
Yeah. Yeah. So to kind of like explain Remark first before like going into like the integration that we helped Remark with. Like Remark is like an NFT Legos essentially. You can have NFTs own NFTs be equipped with NFTs. You can also have non-transferables, which is really nice that that can enable things like Soulbound tokens in general, so that a wallet can't ever transfer this NFT out of its wallet, and utilizing like creating like a palette that other parachains and other like substrate based chains can integrate into their runtime. It makes it really powerful that now you have like these modular NFTs, and you can create some different custom logic. So for instance, for like Phala World and our like contributions to Remark, we were able to help them build out their like core functionality. So this core functionality right now, as it is, you can have your NFTs, and then you can mint an NFT into an NFT like during the minting process, which is good for things like in Phala World for us, we have this concept of a shell NFT that's able to be composed of all these different shell parts, so that you can mint your shell, and then whenever you're minting all the shell parts that are going to be owned by this like base shell part, you can mint them directly into that NFT. So the NFT ends up becoming like you derive a like public key from that NFT, so that it can actually own all the NFTs under it. So this kind of like opens up like a lot of possibilities that you can't do today with NFTs. And yeah, it's I mean, there's a lot more that goes into it, but that's just kind of like the beginning parts that we've like helped them with their like core functionality.
Okay. And I seen where or Zoe mentioned something about the concept of dynamic soulbound tokens.
Yes. Oh, so like for the Phala World?
Yeah.
Oh yeah, yeah. To explain that, so since now these Remark NFTs can be non-transferable, we call this in Phala World a spirit NFT, and the spirit NFT is also connected to your decentralized identity, like my crypto profile, which is done by LidenTree. And this is like a decentralized identity, like data aggregator from all of your accounts that you have connected in that my crypto profile. So for instance, you can have your Binance wallet, you can have your Ethereum wallet, you can have your Kala and Phala wallet addresses added to this my crypto profile for your like Web3 interactions with Phala network in general. And then you have your Web2 aspect of accounts, so like your Discord, your Twitter, your GitHub, your like Phala forum account as well. And this also allows us to aggregate data in from there. And this is all like like privacy preserved through lit entries like secure enclave like technology. I don't know too much about it, but we're able to combine that with the non-transferable Spirit NFT so that we can aggregate all that data in and then configure 4 like attribute scores that directly reflect your contributions and your involvement with Phala Network. So if you're like a developer and you contribute to our code base, then you'll have like one of the attributes will have a higher score for that, along with like mining, staking, trading in general, like trading the Phala token, because we have a Phala token on Ethereum, and we have a Phala token on Polkadot and Kusama with our parachains. So you can also route those tokens between both like the Ethereum network and Polkadot and Kusama networks through a subbridge. So that's like one thing that we can aggregate data from. Another is like, are you promoting on Twitter? Are you promoting on Discord? Like, are you an ambassador? So that's gives them more of a higher score for a different attribute that we have as well. So it really, it turns into more of like a play to build model so that you can really generate like a true like spirit and like something that is tied to your to all your like Web2 and Web3 accounts. So then it's an actual soul. So like, say you do lose the Spirit NFT, well, you won't lose your My Crypto profile that's connected to all your different accounts. So then you can just mint another Spirit and you won't lose all of your like all of your scores, and you can like go through some dispute to say like someone hacked this wallet and you don't want to like have that information on your My Crypto profile.
Now, for this the lit tree collaboration, can you expand on like what they're doing, what you're doing with them, and what that project's all about?
Yeah, I mean, all I know is that they're like a decentralized identity data aggregation protocol. So that's how we're able to use that data meaningfully to create that soulbound data, like that would be tied to your Spirit NFT. So the partnership, like they have their own other projects and other partnerships that they have. So I don't know too much, like too deep into the specifics of what they're doing, other than that we're using their decentralized identity like data aggregation.
Okay. Now, whenever we're talking about the dynamic SBTs, is that like the whole Soulbound 2.0, or is it Soulbound 2.0 something totally different?
Yeah, that's it.
Okay. All right. So going back to the original discussion we had before we started recording with digital inheritance, how do you think that could be integrated with what you're doing, what you are doing at Phala, in Phala world? Do you think that could be integrated in some way?
Yeah, I think it can. And I think like in my mind, I would just do it through like fat contracts whenever they're enabled on our mainnet, because the fat contracts, one, you can derive public key pairs for different chains, and say that you want to do some kind of inheritance, right? Well, then you derive a key pair that never reveals the private key. And then you set up some access control features so that you would be able to say, I want this account and this account and this account to be able to access this function. And if this function is like something that can change the state of the contract, then it would release something like a private key so that they can access the wallet, or it would send the funds directly to them that they can access. So there's like different like things that you can configure with the fat contract to be able to do that for you to have like some kind of like digital inheritance, or you could like bury some treasure or something like that too. It's because like it's and the cool thing is like, since you can derive those like those key pairs within the secure enclave, then you can have it for different chains. So you can have like different tokens from different blockchains in the fat contract, and from there, that's how you're able to like, oh well, based on if this person like calls this function, then it'll trigger a transaction and send it to the wallet that we think that they would own. And then you can have like some kind of like digital inheritance there. But I am interested though in how to like enforce that at the pallet level, which would be really interesting, because like a social recovery pallet, then you can have that integrated in all the like substrate based chain runtimes. And I wonder how that, like, I do wonder how that would work, because like the fat contract idea that I think of is like kind of like a little siloed towards like one solution. I'd wonder how to like do it like more of like a decentralized way to the pallet integration though.
Yeah,
you're doing.
Now, can you expand on what a fat contract is?
Yeah. Yeah. A fat contract is like, let's see. So a fat contract is not a smart contract. It's more of like a smart contract enabler, because we're like Phala network operates on this secure off-chain computation model, which utilizes like secure enclaves in these off-chain workers to be able to one, pass messages back and forth between the Phala blockchain, so that so there's like this message relayer that we call like a ferry, and then you have your like Phala blockchain, and then you have your secure enclave off-chain workers, and they can pass messages back and forth. So all these off-chain workers are also in sync with the Phala blockchain, and they're all separated into different clusters. And these fat contracts are deployed within these like off-chain secure enclave workers. So since they're off-chain workers, now you have like the ability to, one, scale your computation. Two, you can have like instantaneous queries since they're in sync with the blockchain, for the Phala blockchain. So like this is really important, because since you can have like no latency with your queries, you can do a lot more with them. So since they're off-chain, we also have access to the internet. So this access to the internet allows us to make like HTTPS requests, and that means you can like interact with Web 2 or Web 3 services. So it becomes like more of like a middleware, like this like glue that you need to build like Web 3 applications or like hybrid Web 2, Web 3 applications. So it's like the perfect like ingredients for like the Web 2.5 to get us to like the next step of like Web 3 development. At least that's how I see it.
Excellent. Now, can you talk about the rollups we discussed, or that's to be that's
I mean, it'll be to describe more. I would like to be able to like understand it a little bit more to explain it like technically better. But essentially, since we have these like secure enclave off-chain workers, so we have this like privacy preserving aspect. Now we've already proved this on Ethereum and all substrate based chains, but we can derive a key pair within the secure enclave of the fat contract. We can then compose an extrinsic, and with that key pair, we can sign that extrinsic and then send it to an RPC node so that we can execute a transaction. So the roll-up part is, we need like if it's like Ethereum, we would have to deploy like a layer 1 roll-up contract so that we can ensure the state of a transaction. And then the next, like that's where I get like a little cloudy on like the technical like specifics of that part, because I'm not like 100% sure how to explain that correctly, but it's a way for us to like ensure that transactions will go through, and we can not like continuously send transactions from our like from a cluster of off-chain workers, so it doesn't try to like execute a transaction again or something like that. So like that's the part where I'm not really clear on, and I'm trying to get like a little bit a better understanding on that. But you also, so like that's one part where you can deploy this off-chain roll-up contract on the layer 1s. And then there's also the substrate base, so like creating a off-chain roll-up palette so that we can interact with all like substrate based chains and make sure transactions execute on any substrate based chain through the fat contract. So that's like the other aspect as well.
Okay. Now, and another thing we started to talk about was if someone wanted to create a digital inheritance type solution from another blockchain, you were talking about how that would be included in a pair thread, and if it would really need to be included in a pair thread. Do you have any further thoughts on that one?
Yeah, that one's really interesting because I'm not sure how to enforce it per se, but like, because you had mentioned like a pair thread in general is like a pay-as-you-go model, and it does make sense, especially if this is like an inheritance type of contract, because you're not going to have a lot, like, not contract, but like a pallet model, right? The social recovery pallet model. Yeah. So if you're able to like claim your inheritance, it's not going to happen often. So like using a pair thread for this seems like a pretty good idea, because it shouldn't be happening often. But I don't like, it's like really hard for me to like think of like how exactly to do that such that it's like you can ensure that no one can like fake any kind of like claim on an inheritance. That's where I'm like, in my mind is like, how do you break that like idea by using like these pair threads, or in general, like what is the best way to protect your like inheritance in general? And that's where I'm stuck on. I'm like, I really want to know like a little bit more like on the social recovery palette, and then like the whole like architecture that you plan to do.
Mm-hmm.
Yeah, it makes me think a lot. I'm like, but it's such a great idea, like in general, just being able to
that's why we're researching it, my friend.
Yeah.
it's all theory at this point in time.
Yeah. And you said you were talking about like the what was the project you were talking about, like that
Safe Haven's on VeChain.
Okay, and how did they do this?
They just built on VeChain. There's no integration right now. They're just on VeChain. So again, they have a wallet where you can actually, so you'll have like signatories, and then you can actually set up a kind of like a digital will.
Okay.
Like a digital will and testament. So that's kind of where the social recovery palette, I think, could be a good use case within the Polkadot and Kusama ecosystems, where you could kind of set up something like that with the social recovery palette. Similar to what they currently have now.
Exactly. Yeah, that's what I was thinking, is like, if you do it at the palette level, then once you have that palette finished and it works and you can test it out, then it's not, you don't even really need a pair thread. You just then other parachains and substrate based chains, they can just integrate it into their runtime, and now they have
support. So it's kind of like what you all did with Remark. Remark created an NFT solution, and then pretty much any substrate based chain could integrate what Remark created.
Exactly. Yeah.
Oh, okay.
Yeah, that's where I was like, yeah, I don't think you need a pair thread. I think you just need to build the palette and then have other parachains like integrate it. And then if you create some kind of way to say, oh, if you want to create some kind of solution where it's like all these different chains need a signature from this chain, you need a signature from this chain, you need a signature from this chain, then you can use like maybe like XCM like messages to be able to like communicate between that palette across different chains, so that you can like recover whatever, like when it comes to like social recovery, like be able to like use like some kind of like multi-account like signature scheme to be able to
see. This is good. All right, so how could that be one? See, this is what I was trying to get. One, how could there be an aggregator? How could there be an aggregator within the Polkadot and Kusama ecosystems, right? That should be the easy part. And then two, how could there be an aggregator across Ethereum, Phantom, Binance?
Oh yeah.
Right? Because you have to aggregate not just Polkadot and Kusama. You have to bring in Polkadot and you have to bring in Kusama. Then you got to bring in Ethereum, Binance, Polygon, Optimism, everybody. How do you think that would work? I'm not gonna ask you how it works, because how you think that off the top of your head.
There would have to be, because I mean,
Or you have to do them like individually or something.
I think it's like using, like, for instance, like with the subbridge, we're able to like
So
move
what's subbridge? Explain
huh?
subbridge. Explain subbridge.
Yeah, so subbridge is it's like a combination of chain bridge by chainsafe and our XCM router that we developed in-house. So pretty much you can take a EVM based chains token, like if it's Phala right now it's just like the Phala token that we support. It can go into the chain bridge, it goes to here, and then it gets to our XCM router, and our XCM router wraps that into an XCM message so that whichever chain we have like an open HRMP channel with right now, we can route that token over to their chain. Like, so it's like a combination of the technology. So that's why I was like saying like it could be interesting like to connect different chains through some kind of bridging technology and then wrapping in an XCM message, or there's like an agreement between the two chains that understands XCM messages in general, which would be like I think would be better. But it's really hard to like say like how to integrate all the different chains without any kind of security holes, because of like bridging in general is like kind of vulnerable.
Yeah. Current state, very vulnerable.
Mhm. But I mean, potentially you could just use a fat contract to like do that bridging, because the fat contracts are pretty much a bridgeless like cross-chain transaction, so you don't even have to use a bridge. You skip the bridging part.
Fat contract?
Huh?
The fat contract?
Yeah.
So you think a fat contract could actually create the aggregation with Polkadot and Kusama, and then do the communications to like Ethereum, Polygon, Optimism, Binance, Smart Chain. But then what would happen? It would come back. So you would send out the message to all those blockchains, and it would come back to Polkadot, or it would be like a centralized hub. I'm just thinking through this as we're talking through it.
No, yeah, I'm thinking through it too. Because like it's an interesting problem, because if you could just interact, like say you have you have a bunch of, I would have to think about this a little bit more, but the fat contract in general can communicate with all of them, right? So all the different chains. So it'd be a matter of like first signaling, maybe like choosing one of like go into like your accounts on these different changes and like sending an attestation of like my account was compromised and I need to recover it, or somebody like starts a claim on an inheritance and it starts a process in that sense, and that sends like an XCM message to the fat contract, then that triggers something that would send to all the different chains for. Yeah, I don't know if that's a good design though. I had to really think about this and like map it out.
Because it's almost like all this stuff would have to be set up in a social recovery palette, right? Because it was going to be initiated on a social recovery palette, and then I guess the fat contract would initiate it and send out those messages. I'm asking. I have no idea.
You could have like some kind of like you could have the fat contract configured to be polling to query that social recovery palette for the different chains, but I don't know if that's like an efficient solution. So it's like, because then it like yeah, I don't know if it's an efficient solution for that. I really got to think about this social recovery like a little deeper, because there's so many ways to attack it, like attack the problem, and then it's like, okay, well, we did this way. Is that too many steps to get to the inheritance or the social recovery? Like how many steps? Yeah, Because if you do too many steps, then it could get out of whack from one of those steps. And you want to make it as simple as possible for people to for chains to integrate, and then have a flexibility of ensuring that they actually get their claim recovered, whichever.
And then it's almost like, okay, if we're going to be calling all these blockchains, how many are you going to add? Which ones are going to be omitted?
Yeah. Well, I guess that's where you would have to create like some kind of threshold like signature scheme on that. Because like I always thought that like for social recovery, you just need to have like some kind of threshold mechanism to where if you're sending out a claim that you lost access to this wallet and these funds, one, you have to ensure that you can freeze it. I don't know how you would freeze the funds or freeze that account from like moving stuff out. That's a hard part right there. And then two is what like how do you ensure that someone doesn't steal like the like threshold count of accounts that you own? I like, and because like if you want to do like a social recovery, I would think, in my mind, I would think that you wouldn't want the person that has compromised one wallet to know that they can go to that social recovery palette on another chain and then view on the chain, the public blockchain, like the accounts that you
That's
have
a good
for
point.
like, that threshold. Yeah. It's
now
yeah,
you're
that's
now
why,
you're checking, now you're having access to check every single block, every single chain. That's a good point. Damn, that's a good point.
but I guess maybe that's where like maybe like if you talk to like some of the zero knowledge chains, maybe they would have like an interesting like take on it. Maybe like maybe the people from Manta, they might know something potentially. That's where I was thinking like the fat contracts too, because like the fat contracts are privacy preserving. But I don't, it's like you have to have it in practice for you to know like if it's going to be like vulnerable.
Right.
That's like the only scary part. Well, I guess like scary part is like getting hacked first and then the recovery part, or having an inheritance that someone wants to get.
Right. Shoot. It sounded eerie. It sounded easy in theory, right?
It isn't everything, right? That's why like research is like, oh, this is great. 10 years ago, they were like, oh, this is a great technology. And then 10 years ago, it's finally like coming to play because they like figured it out, you know?
Yeah. But I mean, there has to be something for this.
Yeah.
But I think once I talked to Safe Haven, I'm pretty sure they've kind of walked through all this stuff.
That's what I want to know. I'm gonna probably after this just like read up on Safe Haven and like just get a general understanding of how they do it.
There's not that much stuff. There's not that much stuff on YouTube. The best one I found, oh man, I'll send you the link. Let's see here. Shoot. Might send it to you later.
Oh, I see. I found it. I found their digital inheritance enables critical data to remain decentralized while maintaining ease of access with multi-layer security.
There was a good one that I seen. And I talked to the guy.
Okay.
Tyler.
Wow, they have a lot of cool stuff. I need to really look into this. This is interesting.
Well, the thing is, when I was doing my research, they were part of the ICO run. And there are about 4 digital inheritance projects out there during the ICO. They're the only ones that survived.
Dang. Well, I mean, what they're doing is like really powerful for the user. Like being able to like, what I see is like safe ID, safe key for two-factor, multi-factor authentication. Interesting. So, and they're interested in looking at building on top of Polkadot.
Yeah.
They should. I mean, this is kind of like all the stuff that I'm seeing on their site is something that's.
And that's what I was talking. That's what I thought about the parachain. It's like I don't think they would want to go through the whole their parathread. Sorry, I don't think they would want to go through a parachain because they're not going to have the volume. They're not going to have the volume of transactions. I don't think.
Yeah, they could be. I guess they could be a layer 2 potentially. I don't know. I'd be interested to see if they would want to build on Phala. because then you like, if you can build on top of that, if you can build as a layer 2, then you don't have to really worry too much about like your tokenomic model.
Yeah, if you're layer 2, how much, like what would the cost look like to do that?
Well, it depends like where you're building. If you're building on Phala, so like our model is pretty much going to be stake your Phala tokens behind this cluster of workers that you think is going to serve your computational needs, and then once you're staking, you get a percentage based on how much you stake of that computation cluster. And the only thing after that you pay is transactions fees if you do any transactions. But we kind of encourage people to use the queries because the queries are instantaneous, and you can kind of like make transactions on different chains with the queries, so you don't have to pay any like transaction fees with the Phala token doing that. But like say that you're done, like you're like, okay, well, we don't really want to, we don't want to use this computation anymore. Maybe we test it out and we don't like it, or maybe they want to move to a different cluster, then they can just unstake and unstake their token. So it's really like no cost other than transaction fees.
All right, I think I found it. I mean, there's a lot of them, but this one kind of goes decent, has a decent background on Safe Haven. There's 2 more I just found. It was a month ago. I haven't seen those yet. So
Safe Haven, this, I think I remember this now. Whenever I went to ETH Denver, I think I remember seeing this, but I had no idea. That was like my first month at Phala, so I didn't have. I mean, every day I'm learning, but it seems like every
month fire hose then, my friend.
Yeah. Yeah, but it's awesome.
Yeah,
goes by fast. Like I could like, I remember last year, like at this time was whenever I was like doing the hackathon for Phala, trying to like get a job and find a place in blockchain. So it was like,
yeah,
but all the stuff I know now compared to then, I'm like, I didn't know anything then. And then even then I was like, since the like a few months before, I didn't know anything and I knew a lot then. It's like you just keep compounding like all the knowledge you get. And then I think about onboarding students or onboarding like people that are in traditional like Web2 backgrounds. And you're like, it's such a huge like knowledge gap, I guess. Because you have to know about blockchain technology, understand blockchains and cryptocurrencies. Then you also have to understand distributed systems. So there's like this it's very rare for you to get 2 of those. And whenever I came in, I was like, I kind of knew a little bit about like distributed systems. I didn't know anything about cryptography really. So it was like such a huge learning curve.
You're one of the few people that got through the class. I mean, it's crazy.
Oh yeah. I was like surprised that not many people got through it. But that's how I don't know. I always just do things. I'm like, oh yeah, anybody could do it. But I don't really realize like it's hard.
Yes, it's very difficult. It's very difficult. I'm still trying to find a mini Josh.
You'll get
Still trying to find a mini Josh. That
Yeah.
one kid I sent you, that one kid, Charles the second, he's got promise.
Yeah, I saw he's already on a patent, like with the suitcase like plugin for like he has like I read the patent and I was like, oh, that's pretty cool. Like it's pretty like a interesting patent to get just to be able to like charge your phone on the suitcases, on the roller suitcases for your luggage.
Yeah, he's a RIT. Yeah, he's a RIT.
What is that?
Rochester Institute of Technology.
Okay. Is that New York?
Yeah.
Okay.
Upstate.
Upstate.
You don't want to go there. Too cold.
Too cold. Yeah. No.
Too cold.
I'm like, it's like 60 degrees right now in Texas. I'm like freezing.
You got a jacket on at 60. That's crazy.
Yeah.
All right. So yeah, we're gonna stop this recording. I think we're good. Anything else you want to add to the recording? I think we have enough. I think we have enough to look at. We need to look at VeChain. We need to see if VeChain can see if there's value in VeChain. So you think it would be easier for VeChain to do a layer 2 as compared to a parachain?
Yeah, I mean, if they don't want to like handle like tokenomics and like running a bunch of like just building like a blockchain essentially, then yeah. But if they want to build their own blockchain and then be able to interoperate with all the different chains like from their chain using like XCM message passing, maybe. But I think they could be a layer 2. But it just
you're saying because they're going to be if they were to do something like this, they would have to use fat contracts, right? You think? Or
yeah, they could build out their products on fat contracts. Yeah.
Could they develop a solution without fat contracts and just use a social recovery palette?
They could because in the social recovery palette is something that you just integrate into a runtime. So it could be a solution that they could just do palette development and not have to worry about the like tokenomic model, and they can offer these security palettes as like as a service for other parachains to integrate into their runtime. So that's another option too.
But what's the value of them integrating fat contracts?
It's quicker development. It's like writing smart contracts, but like with more power.
Gotcha.
Especially with like the access to the internet. So they would probably like, obviously they have like some really good like products right now. And I'm sure that they would know how to like utilize one, like the privacy preserving aspect of the like secure enclave, and then also like having access to the internet and being able to make cross-chain transactions and interact with decentralized storage or any kind of like any ways to like connect with whatever service they need that's off-chain. So they have like access to all off-chain technology if they needed.
Can you expand on secure enclave? Because you mentioned it a bunch of times.
Oh yeah, so like right now we like support like Intel SGX. So it's like think of it as like a black box on a chip. And we utilize this to be able to like generate a proof to get like all the like hardware, the firmware, the software running on your node, and then that is signed by like a key within this like black box that is like right now it's like Intel. So Intel, like there's like a signing key and then there's a sealing key that like Intel doesn't know about. But the signing key, you're able to sign this, like they call it attestation quote with your like hardware, BIOS, firmware, your software version, sign it with that signing key, send it to the remote Intel attestation service so they can verify your quote. And that once they verify and sign it, that's going to say like, okay, this is a trusted person to run a miner on Phala. So that's like one aspect. And the next aspect is whenever you're executing a program, it'll generate a secure enclave so that your execution state will go all the way through without any untrusted source outside of that secure enclave peeking inside and seeing the contents of that execution. But the proof can come out and then be verified by anybody that's outside of the enclave, but they can't see the contents or what was executed within it. So there's also like a lot of people will say like, oh, well, what about like side channel attacks and stuff like that? But it's like the way our like architecture is, it's that's like a really, really difficult thing to do, and to target a specific miner for a specific contract through end-to-end encrypted like communication. Like it's like pretty infeasible, and a lot of them like require like, you know, replays, like replay attacks, or like kind of like just like I think it's like the electrical, I don't know, it's like that part is like, I don't know how to exactly do it, but it's like really, really infeasible to do. The way that you would really need to attack it is like to find the exploit that destroys all Intel SGX, and then we'd have to like, because like right now we're trying to support like AMD SAV and then ARM Trust Zone and other like secure enclaves, but just kind of like expand the protocol for like decentralization purposes. But right now it's like, that's like what some people like kind of like, what about this? And it's not really feasible right now, but we'll see.
Okay, excellent. All right, so yeah, I think that's enough we have for now. I think we're going to do a follow-up after we do some more research.
Oh yeah, no, definitely. Yeah, I like talking it out because it helps me jog my brain and be like, okay, I need to explain this better, you know, like.
Yeah, I think once we figure out more about the social recovery palette, and once we get on the phone with Safe Haven and kind of get their ideas, I think we'll have to circle back and kind of hash it out from a substrate and Polkadot and Kusama perspective.
Okay, yeah, definitely. Yeah,
all right,
look forward to it.
All right, man.